One of the best ways to explore programming in more detail is by creating your own programming language. We are going to implement a very bare bones language called Boogie, and if you have watched this channel before, you will know that this is the name of my dog. Yes, I've named my programming language after my dog. All I can guarantee you is that what we will do in this video will be very basic and probably full of basic errors. But it will get us started on a path to a more robust and optimized language in the future. We are doing this in Python, not because this is a particularly good idea, as it will be very slow to execute, but Python will allow us to prototype fast, without losing a lot of clarity if you are a beginner at this. In the future we will port the code to C or something similar. To get started, create a new directory on your machine, create a new file for your main source code and open your favorite editor. Like always, we will start a main function, and then we need to open a file that will hold the source code of our programming language. Just hard code this for now, don't overthink it. Let's start a new file to hold the first program in our new language and come up with something that we want to be able to run. I'm going to use labels in this programming language, so I will make one called start. Underneath this label, which is going to act to separate out blocks of code, I want to write something to the console, and just to be different, I'm going to implement the keyword echo to do so. Now then, the first step to get our new language to execute is to convert our lines of code into so-called tokens, which is done by a Lexer. A Lexer, as the name suggests, performs lexical analysis of our source code and restructures everything in such a way that we can feed our code to a parser, but more on that later. Basically, we are reshaping the code to be understood by the computer. Before we continue, let's make sure we import our Lexer and pass it the data it needs. Meanwhile, we will also call the tokenizer function and print some information to the screen so we can see what is going on behind the scenes. Alright, so first thing we need to do is loop over each line of code in the data, which is coming from the file we opened. We start a temporary list, which we will initially leave empty, and we will need a temporary ID variable as well. Next, we loop over each character in the current line of code. As you can see, we have a nested for loop here to do so. Now some people will use regular expressions to tokenize their source code, but that is generally not a good idea. The first thing we will try to recognize is character strings, meaning anything between two double quotes. Upon detecting the first double quote, we set our temporary ID to char and make sure our temporary list is empty. Upon detecting the second double quote, making sure that the temporary ID is already set to char, we will append a new token to our list of tokens, making sure to join our temporary list into a string. Then we empty out our temporary variables. Do not worry, all the characters that are in between the two double quotes will be detected later in the else clause of this if statement. If we recognize a white space and the temporary ID is not set to char, we will just use continue to jump back to the beginning of the inner for loop, because we do not want to do anything with this. Then in the else clause we make sure that our default behavior is to just add the current character to our temporary list. Of course, we also need to detect keywords, so when we see that the current temporary list joined together as a string matches any of our keywords, which currently is only echo, we will append a new token to our list. Its ID will be the keyword and its value will be the keyword that we detected. Finally, we need to handle the detection of labels, which are going to allow us to do a pretty cool trick later on. All we have to do for that is to detect a colon character, which means that we can consider everything currently in the temporary list as the label identifier. Let's just have a quick look what happens when we run our new language. And after fixing a small bug where I left some parentheses out, we can see that indeed we are now in the possession of a nice list of tokens that represent the program we made in our new language. We now need to hand things over to a parser. This will generate something called an abstract syntax tree for us, which is a way to represent the logical execution of our code. This will allow us to map our own language to functions in the host language, keeping intact any blocks, which we represented by labels in our case, and other control flow mechanisms. Let's do this. We define a new instance of the parser we will write, and again print some information to the console to help us out understanding things along the way. Make a new file, call it parser, make an init function and pass in the tokens we generated by way of our Lexer. Also, let's define an empty list to hold our AST or abstract syntax tree. We again need to define a few temporary variables to help us out. Just a general notice while I have you here, Please know that this is in no way the best method to go about this. I was just not overthinking this and going with the flow of my inspiration for this video. In the future we will massively improve on everything. Okay, so we need a for loop to loop over all the tokens we have passed in. We can then start by asking the token if it is a label, and if so we will make a new dictionary that has the label as the key and an empty array as the value. If the current parent in the AST is not the same as what we have just defined, we want to set the current parent to our new AST entry. Then we append this new entry to the AST. If the token is a keyword, and this happens to be the keyword stop, which I will quickly add to the source code of our new language, we create a new entry for our AST and append it. The 0 I add here as a value is basically a dirty hack, and please ignore that for now. We will use a new function called addNode from now on to append things to the AST, to which we will pass the parent and the node we just defined. We are going to loop over the AST to find the entry with a key equal to our parent and then append our new entry into its list. In this way we are able to group the right code under the right label. If the keyword is anything else than stop, we need to detect the parameters that follow, and for this I have devised a bit of a simplified solution. We will check if collect is currently false, which it should be, and then store the current token into the saved variable. Then we set collect to true, so the next iteration we will fall into the else clause of this conditional. When we do the next iteration we will define a new entry for our AST and add a node, giving the saved value and the current value as our inputs, which will join the keyword and its parameter together in the AST. We then set collect back to false. Finally, if the token is a char, we will basically do the same thing as we just did. In fact, this is really where the string behind echo gets joined together with the echo keyword. Let's not forget to import our parser into our main code, and now we can see that we indeed have our AST defined. So, final step, let's write the evaluator, so we can actually make our code do something. We are going to set things up here by making an instance of our evaluator class and then make a new file, call it evaluator, pass in the AST and define a run function. Later we will pass in the AST to our run function as well to kick things off. To make things work we need to check whether the current node is of the type list, and if so we need to loop over each node in that list and then nest another loop that will traverse the dictionaries in each list. We can then pass this node off to an execute function which will map it to Python code. Also, if the current node is of the type dictionary, we need to loop over that and we can instantly pass that node off to the execute function. The execute function needs to check first if the received node is of the type list, because that means it is dealing with nested code and needs to pass the node back to the run function so it will traverse deeper. After all this we can check if the node is the echo ID, and if so we map that to an echo function in this class. There we will just call print with the value of this node, which will print the value to the console. If the ID is stop, we map to a stop function, which will call the built-in quit function. Again, we need to import our new evaluator into our main code. Let's print the output of our program to the console and call our run function, passing in the AST. We can see that our program executes now. Okay, so let's have a little bit more fun with this and add another label or block to our code and use a goto statement to hand off execution to this block. Then we can really see how the control flow relates to the various lists we have set up in our AST. We just need to add goto and also stop to our list of defined keywords, and also make sure that if we catch a new line, we append a new token which is an atom to our list of tokens. An atom is basically a variable that defines itself, or even better, a variable that has the same value as its definition. We need this for our label name so we can use that in conjunction with our goto statement. Then in our parser we need to assign the same behavior for the atom as we did for a character string, just by adding that to the else if clause. Adding the goto statement to our evaluator, using its value to match it to a node tree in our AST, and passing that tree back to the run function will give us the control flow we want. And it's working. So that's where we will leave it for this one, and in the future we will build upon this code base and port it over to a language that is a little bit more robust. Even further down the line we can look into implementing a proper virtual machine. Thank you for watching and have a good day.